Hi, in this video I'm going to talk about SQL and SQL queries and some of my experience with SQL. Certainly, I'm going to discuss some queries that I have came across while doing some work with SQL and Postgres. To get started, you just need to have this one package called PG, which stands for Postgres, and then just import that package and connect to your server configs looks like this. You just need hostname, user, password, database that you can get yourself. Just set up the database. I think that's pretty easy, or else google it how to do that. And then we are off to some of the queries. Now it's worth mentioning that there are some concepts that you need to know about before going into advanced queries. Like, there are few queries that I will explain which are pretty simple to pretty advanced, to be honest, at least for me. So I needed to know these things before I grasp some of them. One of few concepts that I needed to learn in order to work with this query was join. Now if you know join, you can skip few seconds or minutes because I'm going to talk about a join bit. So suppose you have two table, right? And both of the table has some bunch of information, but you need like data some data from one table and some other data from other table. What you do is you join these two tables, but only the specific columns, and then you get a one larger table. It's like merging data from different spreadsheets based on the comma identifier. Pretty simple, huh? Yeah, that's what join is. It's just basically your requirements all in one place. Now we have a certain type of joins like inner join. Now what's the inner join? Now inner join only returns the row which are there in the both columns that being joined. Um, I mean table, both table which are being joined. Now think of it like this way. So you have a list A and list B, and you have some common identifier in some common rows in both A and B, and you like that. Like, if the if that common thing is in A and that common thing is in B, then you need that row. So from that list you can sort out based on some particular common thing that, okay, I need this inner join, I need this inner fields, so I can join these two table and can get a new one. Now I think, just think of inner join as getting common items, alright? So it's not nothing more than that. It sometimes makes me quite confusing, make me confuses because there are so many joins. What can I say? Now the last one is left join that I'm going to talk about here, which is, you know, you have a table in the left, you have table in the right. If there is nothing matching in the table right, you still get all the data from the table left, but and from the table right you get null. But if there is a data on table left, you get that data, right? So that's a left join. Now to think of it in simpler terms, it's like all the data from left side and the data that is matching from the right side, you get all of that. But if there is nothing on the right list, you still get the everything from the left list and some blank spots. So I hope you don't mind that. But that can be simplified over transforming the data. You can always check if there's data that you're trying to match is also present on the right side of the list. If it's not there, it's null. So you can easily check for that. And honestly, it was very helpful while I was doing stuff with that. Left join rocks. uh, there are few more terms that I need to tell you, but those are not really concepts but just helpers. So I will get back to them when I get back to them, meaning when I show you the code. That is right now. Let's start with a simple query. How to count number of records in a particular table? Well, to do that you just need this, and here you need name of table, and that can be you know photos. That's it. And I will tell you what this is. Maybe you can already guess, maybe you're a good developer, but what this is just, give me a second, I ran it wrong. So let's wait for the query to finish executing. By the way, if you have a lot of data in the table, then it's going to take a lot of time. That's what's happening in that case. You see, the clip arts I knew for sure had lot less data than photos, and it executed quite fast, right? So database can be slow based on how much data you have. In the above table there can be millions of records, so it will take time in seconds if not done properly. So yeah, this is just to tell you how to count number of records in a table. This is first query, okay? I You want to note it down, you can, or I will save it in a place in here somewhere, and I will give you the link to this repo so you can refer to that. um all right, so we off to next query, which is one of the useful ones, to be honest. Square parts, let me write square parts. So what it is, I select all the data from cliparts, or just select id created at these two fields from a table called cliparts, which we use to calculate the total number of documents in it, and I limit 10, but then I also offset 5. Means it's basically pagination. If you know pagination, oh, well and good, but if you don't know pagination, that's basically you're saying you already have bunch of records from a list, but you need the next bunch. You already have 5, you need the next 5, or you already had 5 documents, you need 10 more documents after that, after those 5, or after those 50. And that's how you do pagination, basically using or exploiting these two keywords in the Postgres. Won't say exploiting, but you get the idea, right? Now let's see if this query is correct. Voila, we have id and created at, and yeah, this is not very useful information, but if I just write asterisk, it will just fill it with load of data, and we don't need that, right? It's just an example. What else I can show you? Now these are just boring queries. You are fetching, you are calculating total records. It's not really that exciting. Let's move to some queries where you have some data in one table and some other data in other table, but you have foreign keys, so that other data in other table is somehow related to the data in your current table. And this is one of the most common problems, not a problem, most common things you do when you are like coding a serious project or something. And while you do this, you want to maintain one thing: normalization, because if your data is not normalized, you won't know what gets where. So, and that is a pain in the ass, trust me, it is. Now I'm going to paste here a query, and then I will explain it, but it's quite big. It's not that big, but it's quite big. Here it is. A few things: JSON underscore AGG, I will tell you what that is, and then ARRAY, that's array underscore AGG. I will explain these two things, but for now look at here. This can be replaced by an asterisk, right? I'm not going to do that, but I'm just saying you can This is just for fetching data in a structure that we define. Alright, now whatever that structure may be, we will discuss it in a bit. Now for now we are getting data from table called photos, but since photos is a name of the table, I use an alias, or I refer to photos as ph because that's shorter, and you can see ph is being used in a couple of places like here, 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 so in a lot of places. Alright, and also once I get data from photo ph table, I join it with nodes table as node, which is again short form for nodes table, where ph.id means the record that I'm getting from these table. I will take that record's id and I will compare it with content id from the table called nodes. Now, and I compare this one more thing, which is content type, which will be photo, so we know we get a node that is of type photo. Now this is some business logic, but you get the idea. I can like literally remove this, it doesn't even matter. You get the idea. The node table has a foreign key which refers to an actual id of this key, means this foreign key is primary key of something, something else, means it's unique in its own way from some, for some other table. All right, so that's how we join, and then it's a left join for licenses. Then again it's the same logic, license id in the node table, like this table right now. from this from this I got this table, and then I left join this table, and then I join again this table. All right, so if I have node and I left join these things, even if I don't get this, I still have this. All right, because it's quite possible that I have a node but I don't really have that photo, that license. All right, we don't have license. What will we do? We'll just replace it with null. It's no big deal. Now we only get license when license id is equivalent to the id of that particular license that is available in table called licenses. Then again we do join, and here some weird things are happening because we are joining the tagging table by comparing its node with node id, like it's not node, just id with the node id. And then we again join the public tag table that is public, using aliases as tag value on tag id, where I'm comparing this with this, and this, oh, I just did that, this with this, and this with this. Okay, it's pretty confusing, but if you get a mind picture, it will be everything. Where i'm getting I'm doing this conditional now, that is where photo id is greater than 1000 and it's less than, sorry, 10,000 and less than 10,200. So it will basically fetch 200 records. We don't even need that. We just do this. We just need 20 records. All right. Now we also group by photo ID, position, download count, and translation. Don't really even need this, but why the hell not? Okay. Do we need this? No, I don't think so. Now let me just run this query and see what happens. Oh, that I'm doing this instead of this because see, this will just print everything and it won't look that pretty. But here we will just slice that array and get two documents, and that will be in a way beautified. See how ugly this is and how much this is. Instead, what we will do is we'll just get two documents. Okay, now we have two documents, and the thing is, I didn't explain you. Sorry, I forgot to explain actually that I that JSON AGG, and that's called aggregation and called array aggregation. So JSON aggregation, it's an aggregation function, all right. It's a function that that SQL provides on its own to aggregate data and combine multiple rows into a single JSON array, if you know what I mean. This is pretty simple, and it is very useful because we have number of tags. See, we have one of these, we have one of these, we have one of these, but we have multiple of these. This is a pain, right? Now what we do is we have multiple tags. We have this, for each tag we have this score, and that comes from different table called tg, and this comes from different table that called tag value, and this is tg is for tagging, that was a table. So over and all, this is a pretty confusing um, data structure, and even here we can get data like this. See, but the all data is normalized. Now thing to mention here is this tag id and this tag position are mapped to each other, even though they are normalized. They are in a separate, you know, they are in a separate array. This particular thing, suppose if the index of this thing is 10, then here the index 10, suppose this is index 10 or this is index 10, then those two map each other, means the same tag has that tag id and this tag position, and here this tag score. Even though it all looks same, but if this were different data, it will all be same. Like this tag id, the tag id 126 has 16 as tag position and 0 as tag score, or 95 as tag score. You get my idea, you know what I'm trying to say. What's the next thing? So next thing is, you say I take id because id is so common. It's in photo, it's in node, it's in license, everywhere. So I name it as photo id. I did the same in the table, I am doing the same in the selecting, when I'm selecting a particular field, a column, if I must say. And you can say like how much we can do with when we are like making some complex SQL queries, and this is not even the most complex query, trust me. Now there is array agg. Array agg again is an aggregation function in SQL to group multiple values from different row into an array. Okay, now you can say like what's the difference? There is none except for the JSON thing, and it all really looks same. This is array agg, and this is the JSON one, and this is also the JSON one. And who am I to judge? You can also decide on your own. It's literally same for me. There's no difference. Now that's it. It's just a way of selecting particular data in a particular format to group them together in a normalized way. There is no nested data inside this. It's just either it's an array, or by the way, these are two different documents. Document 1 ends here, document 2 starts here. I like the document 2 because it's smaller. So this tag id belongs to this tag position, belongs to this tag score. So tag id of 0, tag position of 0, and tag score, just score of 0, index, they bind together and create one object. Then this photo id created at node id position, and even this position, if it seems confusing to you, it doesn't to me, but if it is to you, you can change it to like photo or node position or whatever you want. This is the name that you're gonna see in the end, and you want to know. See, created at is as it is because it is from the photo, but then it is here also created at, and I call it license created at, so it makes all the difference in the world. Now this is a good query. Okay, you can write a transformer for this query and convert it to something else, a more structured data for some other DB, for some UI, for your post processing, or some other service. I don't really care. I hope you understood this one, because we are going to next one, and that's, see, in this one we are using normalizing. That means we normalize data into non-nested way. There's nothing nested here. In the next query we will group data in a nested way. So like that particular thing is a license, the other particular thing is tag or whatever. So it's more clear, and we will use just mostly the same things, trust me. Let me grab that beautiful query for you, and here it is. Alright, now this query seems a little off to you, then it's alright, like I will explain it to you. This part can be replaced by asterisk again, because this is just selecting data, except for this part, because here we are just making a inner query, a query inside a query. Yes, this is possible. This executes and this executes either in parallel, or this executes first, I forgot, but something like that. This executes first, I guess, or parallel, and that this whole query takes response of this query and puts it under the tags. This is subquery, right? So this takes this whole response of this subquery and put it under tags, which is a key of an under an object, and this value will be the key value. So this will be an object, kind of like nested, if you get what I mean. And of course it's tagged, so it's an array, right? Let's start from here. We select photos ID, then select created at, and these are the two things we select from table photo. I think that's clear. Then we have JSON build object. Now I mean, you can guess what a JSON build object does, right? JSON build object builds a object that is JSON-ish, because this is SQL. There is nothing JSON by default, so you need to put there a JSON, so it tells you, okay, this is a JSON kind object, and then it builds that object for you, whose key is this. So in the whole response, you will see something like this. I'm sorry, you will see something like this here, and like blah blah blah. Here there will be fields. I don't care about them. I mean, we don't care about them. And at this point here we have node, and like this, and that's what this JSON build object does. And then JSON build object is the key, the value is again JSON build object, means its value, if it was not JSON build object, its value would be like 2 or 3 or 1 or 2 something, but it's not like that. It's an JSON build object again, so its value is again an object, and I select nodes.id, means ID, and then ID will be like 3 or something, probably more, but just an idea. And then created at, and then this will like this. So we are just imagining how it might look like. Okay, I can just simply run a query, which I will. I'm just telling you what a JSON build object does. It's a pretty self-explanatory word, and inside above there will be like ID 32, and we'll like created at. This is coming from photos, this is coming from node, and all the other tables. See, this normalized data is from the base table, which we are initially fetching from, and then there is a left join from nodes table. So if node table is null, it can go to hell, it doesn't matter. And here you can notice, like, we are not fetching or writing a join for that weird tagging or tag table here, because it was too much of a pain, so we put it in the subquery. And yeah, I will give you a fun fact later about kind of a comparison between these two queries that we did. And yeah, here's the number, like what we do. And then there's a group by. It is required. I don't ask me why. If you don't do this, you will get some weird kind of error. It will tell you to group by. So yeah, it's a no-brainer. How about that? Huh. And even if you want to join more tables like license and stuff like that, if you have more tables, you can just copy the same thing and yeah, create an object or something. Or if you don't want an object here, you can just, do this, nodes dot id. That's it. You just needed to do this, and now it won't return an object. Instead, it will return an id to the node. So it will look like this. Instead of this, it will look like 3. That's it. How weird is that? It's pretty easy, right? And you are getting a nested kind of data, which is pretty cool. Now let's move to this query. We are going to select, and then I can replace this with asterisk. It will give me all data, but instead I'm making an array, which makes sense because tag is a key. So it will be like tags, and there will be an array because of what? Because of JSON egg. And then inside the array, each item will be an object called tag, because we just wrote inside the array we have a JSON object. Like each item inside my really bad this is bad of me, and each item inside is a tag, is an object because of this. And first object look like this, like first key, I would say, tag. And again this tag is an object because I will show you which it is. And then there is a score, which is a number, which is mostly 0 for some reason, and that's not related to the video. And tag, and the second argument of the object will be key and value. The value is again the same object, and then it has id and created at this will expand itself, id, and there's this created at. Now if you like visualization like me, you will see this is very easy, right? This is not very hard. And I used to think SQL is this hard language that gives some weird data in a weird shape, and what would I do with it, and how do I process it, how do I transform it. You don't have to actually write transformations. Like in this query, you would need to write transformation, right? This is ugly, but if I run this query now, I would get a pretty version of the same thing. Just same data, same everything, I'm transforming within the query, which I think is very cool. It will save me it will definitely save me some line of codes, I know that. So the fun fact, coming to the fun fact now, the fun fact is this way is actually faster than the previous way. For some reason, maybe because of the subquery, this thing is faster than the previous one, the normalized way I showed you in the previous query. Then you can ask me, why do you show the slow one? Because that's the most popular one. Even I was using that before I thought of doing it this way, and that's the truth. And that's why I'm making a video now. Okay, now let's see, what do we get. Actually, you know what will be funny? The funny thing will be if we use the same IDs as we did for the similar IDs or the same object that we saw in the previous. Let me just fetch it. In the meantime, I will show you what this is doing. I'm just getting the same data as I was getting in the previous one, so you can have something. Let me just do this. So this is the first object. You can see ID is there, created at is there, and then there is a node, and inside a node there is again an object called node. Weird enough, but it is fine, really, trust me, this is fine. Then it has this data node and created at, and you would say, yeah, this looks odd, but then you can go fix yourself, like this is simple, I can give you a patch, but who cares at this point. Node, and then you can access all the properties. Then there is a tag, and inside a tag it is an object, it's an array of object tags, and inside that array of objects you have again tag that is an object. Inside that you have some key value pairs and a key value pair outside the tags. And it fetched, or it didn't, who cares. But like, here's the thing, you got the array, you got the data, you ask about nodes in a separate object, and you get a normalized data in here. And instead of getting this normalized data, you could have made it like this. It's just us who didn't want that, or me who wanted to show you like this. It is pretty simple. Here I will show you the result. Now we have no data on the top level, at least no normalized data on the top level. On the top level there will be just objects, bunch of objects that represent each of the joining table's data. And yeah, let's start from the top. This is the first record that we get, and then we get photo. Inside the photo we again have photo and then we have ID and created at, and then inside the node we have node, ignore this, and then we have ID and created at. Could have asked for different record, but who cares. And then again this goes on. This is pretty cool. This is my favorite way of getting data when you have complex data structure like this. I hope you like all of this, and as I told you, this is even actually faster if you write this like subqueries than just getting everything from here and then sorting everything here in a normalized way. That's boring. So do it like this, transform it while you fetch data, and yeah, play around with it. You might get fun. If you want this code, all of the queries, 4 or 5 queries that I ran, you will get access to them in the GitHub repo. Thank you for watching. See you in the next one. Bye.